Let's look at how we structure code in object-oriented programming. While variables represent the data a system holds, methods define the behavior, the actions that can be taken with that data. In Python, methods are categorized into three distinct types: instance methods, class methods, and static methods. Understanding these categories is exactly what separates introductory level programming from professional grade software engineering. Instance methods are the most common type and are used to perform actions on one specific object. Class methods operate on the class itself, meaning they can affect every object created from that class. And static methods serve as helper functions that are stored inside a class for organization but do not require access to the specific data of the object or the class. To really understand how these methods interact with data, let's look at the environment of a restaurant's kitchen. An instance method is exactly like a chef cooking a specific customer's order. The chef is looking at this order ticket right here and working on this specific dish right now. In code, we represent this specific focus on a single object using the keyword self. Moving to the middle, a class method is comparable to the head chef changing the entire restaurant's menu for the day. This action does not just affect one plate, it changes the rules for the whole kitchen and every meal served thereafter. In code, this higher-level action is represented by the keyword CLS, which stands for the class itself. Finally, on the right, a static method is like a calculator sitting on the kitchen counter used to convert temperatures. While the calculator is located in the kitchen for convenience, it does not need to know about the current orders or the menu to function. It just performs a specific independent task. We define these using the @static method decorator. The key takeaway is that your choice of method depends entirely on whether the action needs to modify a single object, the overarching class rules, or neither. Now let's explore the specific rules defining how these three methods access data and their different requirement levels.
The differences in how these methods access data are defined by specific rules. As we can see, organized across this board, your methods are categorized by their requirements and what data they are permitted to touch. Let's start by looking at the instance method. This is the most common type you will write. Notice that it uses self as its first parameter, which directly represents the specific object you're working with. Because it is tied to an object, it has the broadest access. It can see and modify both instance variables, meaning data unique to one object, and class variables that are shared by all. A great practical example here is giveRaise function, which takes an amount and updates the salary for only one specific employee. You call it directly on the object, like emp1.giveRaise. Now moving over to the middle, we have the class method, which you identify in your code using the @class method decorator. Here, the first parameter isn't self, it's class, representing the class itself. This changes what it is allowed to do. It can access class variables only and cannot see individual specific instance data at all. So a perfect real-world example here would be getHeadCount. This counts all employees across the entire company rather than looking at just one isolated person. You call it on the class itself, like employee.getHeadCount. Finally, we have the static method. You flag this using the @static method decorator. This one is unique because it requires no mandatory first parameter, no self, and no class. It acts as a pure utility function. Because it doesn't take the object or the class, it has access to neither instance nor class data. We use it for tasks like is retirement age, which just takes a year and performs a mathematical calculation. It doesn't need to know anything about a specific employee or the company state to do its job. The key takeaway here is that your choice of method dictates exactly what data it is allowed to interact with. Instances, the whole class, or nothing at all. Let's see how these different access levels might look in an industrial setting, like managing an oil and gas pipeline. Now that we understand the rules for these methods, let's see how they are applied in the real world to solve actual problems. Let's look at the oil and gas industry, like a company such as ONGC. They use these programming concepts to manage massive physical networks. If you want to inspect a specific part of the pipeline, you use an instance method. A method like check pressure acts on just one specific section. For example, reading the gauge on section 1 right here. It only needs data from that single pipe. But what if you need a high-level view? A class method looks at the entire network. A method like getTotalSections returns the total number of sections across the whole system. It deals with the collective group, not one individual pipe. Finally, we have the static method. Think of this as a simple utility tool, like converting PSI to bar. It's purely a mathematical task. It doesn't require any specific information about the pipeline to do its job. This same exact architecture applies to software too. Salesforce CRM utilizes this structure to keep millions of lines of code organized and maintainable. When you need to interact with just one customer, they use instance methods to update the status of a single lead, like updating LSS record to contacted. To see how the business is doing overall, they use class methods to generate reports across all leads in the system. And for everyday formatting tasks, like standardizing dates or converting currencies, they rely on static methods, since these utilities don't need to know anything about the specific leads themselves. The core takeaway here is that instance methods act on one individual item, class methods act on the entire group, and static methods are just independent helper tools. Next, we will look at how these three concepts are actually written in code using a specific employee class example. Let's put everything we've learned into practice by looking at a complete employee class structure. It begins with some class variables at the top. We have company set to Infosys and employee count starting at 0. These are shared by every single employee we create. Our init method sets up the individual data like name, salary, and birth year. Every time a new employee is created, we make sure to run this line of code to update the shared employee count. Now let's look at the three types of methods we can add to this class. The first behavior defined is an instance method. Look at the implementation details for giveRaise. Because it uses self, it can specifically target self.salary. This ensures that if you give a raise of 10,000 rupees, only that specific employee's salary changes, like Ravi's. Next is a class method, which is always marked by the class method decorator. A great example is getHeadCount. This method uses CLS to access CLS.employeeCount. It doesn't care about Ravi or Priya specifically, it only cares about the total number of employees tracked by the class. Class methods are also frequently used as alternative constructors. For example, the from string method allows you to create an employee object from a single block of text. You can pass in a string like Priya-95,000-1990 and the method splits it into parts to build the object. This is a very common pattern in professional coding for handling different data formats. The final behavior is the static method. Look at isRetirementAge. This method does not use self or CLS. It performs a standalone mathematical calculation. It takes the current year, which is 2025, and subtracts the birth year, let's say 1960. It calculates the age is 65. Then it checks, is that age greater than or equal to 60? Since it is, it returns true. Let's see how we use these in a real scenario. First, we create Ravi normally. Second, we create Priya using a from string class method. Third, we call giveRaise on EMP1, which only affects Ravi. Fourth, we call getHeadCount on the class itself, returning 2.
And fifth, we check the retirement age, again calling it directly on the employee class, which simply runs our math and returns true. To quickly test your intuition, imagine a warehouse inventory system. An instance method updates the stock of one specific item, a class method calculates the total value of all items combined, and a static method calculates the volume of a box, since length times width times height is just general math. And remember, if you try to use self inside a static method, Python will throw a name error because static methods are intentionally completely isolated from object data. For your final practice, try building an order class for an e-commerce system. You'll need an instance method to apply a discount to a specific cart, a class method to track the total number of orders placed globally, and a static method to calculate an 18% GST on a given amount. The key takeaway is that designing your classes with the correct method types creates a robust system that perfectly separates individual actions, global tracking, and general utilities.